so I hope everybody understands this.
Oh my god.
Time for the theories. The stuff that some smart people thought of. String theory, the main topic, was first proposed in 1943 by this dude named Werner Heisenberg. Nobody paid much attention though, because
Reasons.
there was a war going on and people were trying to make a bomb.
Yes.
Yeah.
Nobody's attention
A
to
big
theories
ball.
while there's war going on.
Yeah, no time for that. No time for thoughts. It probably in 1960, once the war ended, and people discovered this dude's work. They're like, you know, this is some nice stuff. We should have paid attention to this earlier. Let's work on it more.
Oh.
I was saying my little things called strings. More on those later. I'll explain them in detail in the next slide. Based on the concept of gravitons, they're in this too. They're gravity particles that transmit gravity. In depth later. Back to the strings. So, they're one-dimensional particles, although they're kind of one-dimensional. If you want to count the one proton width they have in width, you can call them two-dimensional, but I mean, whatever. Strings can either be open or closed, and operates on a scale of Planck length 10 to the negative 35 meters, which is like 0 followed by 35 zeros and then a 1 of a meter. It's that small. Cosmic strings are also a thing. They're strings that operate with wormholes. More on those later. And they were first theorized in 1976 by Tom Kibble. That's his last name.
Well,
I
okay.
don't know. And string theory says that particles are just strings that vibrate differently. Yeah. And they might hold wormholes open, cosmic strings. Which happens to be our next topic, wormholes. First variant theorized by Einstein and Albert Einstein, that was his first name, and fellow physicist Nathan Rosen in 1935. Needs new type of matter to be crossable. This new type of matter is called exotic matter. It's matter with negative mass that pushes stuff away. So that's what we need. Maybe portals to other universes. Keyword there is may. We don't know.
We don't know.
Man have existed since the birth of the universe with the cosmic strings. And now we need an explanation on cosmic strings. Okay, so in like the very first tiny fractions of a second of the universe, right? Everything was very tiny and very hot. And ridiculously shortly after that, you know, it expanded, it went boom. And all the fundamental forces kind of just split up, but not uniformly. Think of it like freezing an ice cube. If you freeze an ice cube, it's not just all frozen. Some bits freeze differently than the other bits. So, and create like little air bubbles and whatnot. The equivalent of those air bubbles in the universe are the cosmic strings. They expand with the universe. They have 1 point, 2 points. They have 2 points, 1 point, one end of the universe, another point in the other. Go through one, come out the other. It's wormholes. Supersymmetry. Supersymmetry says that for every particle, there's another particle with a different spin. And here's what spin is. Spin is the amount of angular momentum that said particle carries/transmits. Right? So, say I had a particle with a spin of like 2. Something like that, yeah.
Yeah.
First proposed in 1966. It was not explained well, so nobody understood. Was proposed again in 1974, much better, by two physicists named Jules West, yeah, and Bruno Zumino. Without the string theory, or the world would collapse because we'll get to that later. It's on the next slide. Yeah. M theory. Named for a possible grand unification theory, theorized in 1996 in a physics conference, like August. A dude named Edward Witten. And he basically said that, well, at the time there were like 5 different other kinds of string theory that people were arguing about. And he said, hold up, what if all these theories are just different ways of explaining the same theory? That's M theory.
So,
And quick little thing you need to know. String theory operates with 10 dimensions. 1995, dang. It adds an extra dimension to string theory, making it 11. But, kind of like, gets rid of 6 other dimensions because they apply to scales so small that nobody uses them. And, you know, nobody observes that. No one knows why it's called M theory. Seriously, I don't know.
Why don't they just ask him then?
it's Mason.
I don't think he told me.
Mason theory.
Yeah, no.
Oh wow.
Very secretive dude. As promised, the graviton.
Wow.
Term originally coined by Russian physicists in 1934. Everybody knew about it then because Russia.
Yeah.
Then brought back in 1959 by Paul Dirac after he was done working on a bomb. The quantum of gravity. And here's what quantum is. So, quantum is a particle that transmits a thing. So, a photon is a particle that transmits light. Making sense? Yeah. So, gravitons would be a particle that transmits gravity.
Just transmits just gravity?
Yup.
Straight up
Transmits
Okay.
gravity.
I don't see it. Okay.
Very, very hard to detect. Will often get confused with neutrinos, which are like tiny little things that pass through everything and come from radiation, nuclear fusion. Come from the sun. Both of them. Yeah. Particles and forces. Because you need to know about this stuff too. The fundamental forces. The 5 forces that make everything happen. Maybe it's 4. Yeah, it's 4 thing. Gravity. It holds you to Earth. What more do you want me to say? Weak force. It manages radioactive decay and nuclear fusion by controlling how they split and where stuff goes and stuff like that. Strong force manages holding atoms and quarks together by their quantum is gluons. They transmit force by holding stuff together. They're what makes neutrons and protons stay together with the quarks. Quarks are tiny little things inside neutrons and protons. More on this later. Electromagnetism manages electrons and binding particles of opposite charges together because we need that to happen. Bosons have whole numbered spin, so a whole numbered angular momentum. Bosons consist of gluons, transmit strong force. Photons transmit light. And Z and W bosons control the weak forces. Weak force. Yeah. Oh, electromagnetism and light. Yeah. Fermions, they're everything else. So, they spin at fraction speeds. 5 halves, 1 half. Goes on. Fermions consist of quarks and leptons. Leptons are tiny little things that don't exist for very long unless it's an electron. We'll get to those in just a second. There are 6 types of quarks and 4 types of leptons. 6 types of quarks. up, down, top, bottom, charm, and strange. Up and down, the other ones don't really matter. They make up the stuff. Leptons, they are electrons, muons, neutrinos, and taus. Muons and taus last for like a couple billionths of a second, so they don't really do much. Neutrinos, they're just too fast to do anything, go through everything. And electrons, they make that work, and that work.
Nope.
So
That work.
without those, you wouldn't be hearing this, seeing this. So they're important, to say the least. The Standard Model helps us describe four fundamental forces, because gravitons are a theory, we don't know if they exist. And it's very nearly the theory of everything. We need those gravitons. It was formulated in 1954 by physicists Yang Chen Ning and Robert Mills.
Wow.
The final particle, the Higgs boson, was discovered in the Large Hadron Collider by smashing things together. That's what they do best. And that would be it.
How many
This
slides?
14.
Yeah.